Hey, Mr. Harrod, I'm going on to part 2 of strong acids and strong bases. Okay? Now, you need to...
Hey, listen! Hey, listen! Hey, listen!
Okay? You have to watch out for these tricky bases that I sort of warned you about in the first video, but I need to warn you about in this one. You have to watch out for your calcium hydroxides, your strontium hydroxides, and your barium hydroxides. Because these are the ones that have 1 to 2 mole ratios that you have to watch out for. Okay? So, first question here. What is the pH of 0.0682 molar strontium? I know your paper says strontium hydroxide solution. First thing we need to do is the dissociation. Okay? Since this is a strong base, strontium hydroxide is going to be aqueous and is going to dissociate into strontium ion and into hydroxide ion, 2 of them, correct? And I think technically it's ionization, dissociation. Dissociation, I think, is technically for ionic compounds. Ionization is technically for acid bases. Okay, whatever. Okay, so next thing we have to do is find OH minus with a mole ratio. Hey, because you know I love my mole ratios here. So in this question here, we are starting off with 0.0682 molar strontium hydroxide. We are going to find the moles of OH, and we're going to take that over the moles of strontium hydroxide. So this is a 2 to 1 ratio this way, so you multiply this by 2, and you get 0.1364 molar OH. Okay. And then finally here, find pH with POH and OH minus. Okay? Since this is OH minus here, I am going to do POH equals the negative log of OH. Because it's not the pH, because I have the OH. So you have to do POH equals the negative log of 0.1364. POH equals 0.865. Then I am going to do pH plus POH equals 14. pH plus 0.865 equals 14, so I'm going to subtract 0.865 from 14. And I get a pH of 13.1 if I round for sig figs. Okay. See? Easily done. Can't be that hard, right? Definitely not. Right? Right. As I get my next pen ready. Okay, wonderful. Okay, some of the problems you have to go in reverse here. So, for instance, here, if the pH of barium hydroxide solution is known to be 10.4, what is the original molar concentration of the base? So here, we have the pH is equal to 10.4. So we're going to use pH equations to find OH minus. So we know pH plus POH equals 14. We know the pH is equal to 10.4, so plus POH equals 14. So then we know POH must be equal to 3.6. But we need the OH minus because we're trying to find the molarity. So we do OH minus is equal to 10 to the negative POH. OH minus is equal to 10 to the negative 3.6, which is equal to 2.51 times 10 to the negative 4th molar OH. This is one of those problems that's the reverse of what we're doing on top. Okay? Next thing we need on this one here is we need a dissociation equation. Okay. We are starting off with barium hydroxide, which is aqueous. This is one of those tricky ones, those tricky strong bases, because it goes to barium ion and 2 hydroxide ions, aqueous and aqueous. Okay. Because now we're going to find the molarity using mole ratios. Now this one's a little tricky here. What you have to realize here is that this is 2.51 times 10 to the negative 4th molar OH minus. So if I'm trying to find the original concentration here, moles of OH minus goes on the bottom to cancel out. And I'm going to put moles of barium hydroxide on the top. So this time it is 1 over 2 because we're going that way. Because this is moles of OH, so moles of OH goes on the bottom, so you need the 2 down here. So you end up dividing by 2 here. And I'm trying to round this to 3 sig figs, probably, right? So this is 0.136 molar barium hydroxide. See? Easily done. Okay. Okay, here's the last one we're going to do here. I'm hoping you can see that. I can see it on my screen. I'm hoping you can see it on your screen, what I wrote there. Okay, 8.17 of 4.5 grams of potassium hydroxide are dissolved in 500 milliliters of water. What is the pH of the solution here? So on this one here, okay, they didn't give us the molarity of the potassium hydroxide, which we know is KOH. So we have to find molarity first. Okay. So here we have to go back to chapter 7 here, and we're going to use the formula molarity equals mass over molar mass over liters. Okay, so let's see here. Our mass is 4.5 grams. Molar mass, so I have to do K, O, and H. 1, 1, and 1. 39.10. Love these pens, by the way. Pens make me so happy. So happy. 39.10. 16.00. 1.01. 1.01. I think I end up with 56.11 G/moles. Down with the gangsters. So 56.11 grams per mole over 500 milliliters, which is really 0.500 liters. You solve that, and you end up with 0.160 molar KOH. Okay, next thing you do here, have to do the dissociation equation. Since this is KOH aqueous, this is going to dissociate into K plus aqueous and OH minus aqueous. Okay. Then we are going to do the molarity of OH using mole ratios. So we know we have 0.160 molar KOH. So we're going to put moles of KOH on the bottom. We're going to put moles of OH on the top. Luckily for us, it's 1 to 1, which gives us a molar of OH of 0.160 molar OH. Then finally here, we're going to do find pH with equations. So we're going to do POH equals the negative log of OH. POH equals the negative log of 0.160. POH equals 0.794. Did you know I can do logs in my head? Oh yeah, I can. Then we do pH plus POH equals 14. 0.794 equals 14. pH equals 13.21, which has a sig issue, but I don't want to discuss that with you right now. Okay, guys, champions, the legend is out.